So the next piece that we need to talk about is writing general statements and interpreting. So we want to be able to tell someone, or if we're asked, for example, on our coast curve, when will our coast curve have a value of 1/2? So for what values of theta will our coast curve have a y value of 1/2? And so we can use our curves and our information to write that. So we could write a general statement so that we could tell our reader for all values of theta on our coast curve where we will get a y value of 1/2. And this can be really helpful when we start to get into our application problems, into those word problems. So I've gone ahead and I've drawn your coast curve. I've drawn two rotations of it because that's going to really help us to see what we're looking at. So I just want you to first focus on our coast curve, and I want you to notice the values that I've plotted for my coast curve. And so what I'm hoping you'll notice is that all I've plotted was my max, my 0, my min, my 0, and my max. So those 5 key points are the key points that I care about when you're drawing that coast curve. Same with sine. So we're being asked to identify for what angles of theta do we have a y value of 1/2. So first let's go through our graph and we can identify where do we have a y value of 1/2. So where's my y value of 1/2? Okay, so we've done that. So really, if we were just to list values, we could have just listed, well, okay, theta is at a value of 1/2. That's going to be pi by 3. And again, if you're wondering if this is a pi by 6 more gives me pi by 3. It's going to be at a value of 1/2 at 5 pi by 3. I'm pi by 3 shy of that full rotation. And then I could also give negative values. I have a theta could have been a negative pi by 3. Or we see that at negative 5 pi by 3. So those would be all values of theta that we see on these two rotations for angles that produce a y value of 1/2. But we are being asked to write a general statement. So a general statement is inclusive of all values of theta. So what you'll notice, I'm hoping you'll notice anyways, the distance between these two y values of 1/2 and the distance between these two y values of 1/2 are not the same. And we can tell that purely by just counting grids, right? The number of grids between our first two y values of 1/2 and the number of grids between our next two y value of 1/2 are not the same. So that leads you to the question that I have written there in purple. Whenever you are writing a general statement for yourself, you want to ask yourself, do my y values repeat at regular intervals? If they do, if your answer to that question is yes, they do, then you need to write for yourself only one general statement. Okay, so if your answer is yes, then you need one statement. If your answer is no, they do not repeat at regular intervals. And again, you'll notice here, our y values are not repeating at regular intervals, right? The distance between those y values changes. So in this case, we would have to write for ourselves two general statements. So our next question should be, okay, that's great. I have to write two statements, but how do I know how to write those statements? And again, the reason why is because we need to write a statement that tells us over and over and over how we can predict our next angle that will give us a y value of 1/2. So I want to draw your attention to, we know that cos rotates a full cycle every 2 pi units. So I want you to notice, as I approach this y value of 1/2, I am rising. My cos curve, if I move from left to right, is rising to that y value of 1/2. And you'll notice if I rotate 2 pi later, so if I go a full rotation, I am rising again to that y value of 1/2. So again, I am rising to that y value of 1/2. I would go a full 2 pi rotation and I'm back to recognizing I'm rising to a y value of 1/2. So that's going to allow me to write one of my general statements. So for that statement, I have theta is equal to, and I can pick where I want to start my first value of theta. So maybe we say I'm going to start that first value of theta at negative pi by 3, because that's my angle. How can I predict to someone when my next value of what for my next angle, what that will give me for my y value of 1/2? Well, we just said it's going to be a full rotation later. So 2 pi later, if I add 2 pi to negative pi by 3, I'm going to get my next angle location. And we know that that next angle location is at 5 pi by 3. But that was one rotation later. What if I wanted to know what angle 5 rotations from now will give me a y value of 1/2? So we are going to include, attached to our 2 pi, a k. And that's going to represent just how many cycles. So that could represent positive cycles in the future. It could represent negative rotations backwards, right? So it can rotate positive rotations and negative rotations. But the one thing we need to note is if it has to be every 2 pi, if we are only rising to a value of 1/2 every 2 pi, that means 2 pi, 4 pi, 6 pi, or a negative 2 pi, a negative 4 pi, a negative 6 pi. We cannot have a half rotation. So we need to make sure that k is an element of integers. K has to be an integer because I need it to be a full rotation. If it's only a part rotation, if k was 0.5, well, that only gets me to 3 pi, and we can look at our graph and notice there is no y value of 1/2 at that value. Okay, so that's our notation for being able to write our general statement. But since we said our y values do not repeat at regular intervals, we need another general statement because we've said we need 2 statements. So I'm hoping we can notice that when we look at our other values, if I go along my cos curve from left to right, I notice that I can fall to a y value of 1/2. And falling to a y value of 1/2, well, that I can write in terms of an interval because that's going to occur a full rotation. So every 2 pi, I get back to that y value of 1/2 and I fall to that y value of 1/2. So for this one where I'm falling to my y value of 1/2, maybe I pick pi by 3 for theta. So I can say theta is equal to pi by 3. When does it fall to a y value of 1/2 again? Well, it has to take a full rotation in this case, so I have to write it as 2 pi. But since I'm writing a general statement for any number of cycles, so any number of rotations, positive or negative, I'm going to include my k. And in order to make sure that it rotates a full 2 pi, I need to ensure that k is an integer. So we have 2 statements to represent when, for what values of theta will we have a y value of 1/2. And what helped us to identify those was when it was rising. So this one we looked at, when was it rising to a y value of 1/2. And this one talked about when was it falling to a y value of 1/2. For those statements, I chose a negative pi by 3 for theta. I could have chosen instead 5 pi by 3 plus 2 pi theta. So again, it doesn't matter which of those starting points I choose as my initial value for theta. So I could have said theta equals 5 pi by 3 plus 2 pi k. K is an element of integers, because if k was a -1, in this case, if k was a -1, it would have been 5 pi by 3 minus 2 pi, which would get me back to that negative pi by 3, right? So it would still be a value of theta that exists for when it is rising to a y value of 1/2. So for example 2, I've already drawn the sketch of y equals sine theta. And to help us really get the full picture of this, I've done 2 rotations of sine. Okay, so our first question is asking, for what values of theta do we have y values of 0? Right, so for what values of theta do we have y values of 0? So if I look at my sine curve, for what values of theta do I have y values of 0? So if you recall, our first thing, let's identify where those values are. Your next question that you're asking yourself is, do the y values repeat at regular intervals? Do those y values repeat at regular intervals? And I'm hoping when we look at that, we notice that there are the same number of grid points in between each of those values. So our y values do repeat at regular intervals. So what this means is we need one general statement. So because they repeat at regular intervals, we need one statement. Again, if we think about the most efficient way that we could write this, so maybe you go, okay, well, I can start at 0. How long does it take to get to that next y value? So if we look, do you notice it only takes pi units to get to our next y value of 0? So we rotate, we continue on our curve, and pi units later, we're at a y value of 0. We continue to rotate, pi units later, we're at a value of 0, a y value of 0. So we can say, instead of it being a 2 pi times k, we want to write that even more specifically because we would be missing some values. So we can say plus pi k, and k is an element of integers. Now I'm hoping we would just simplify that to say the values of theta would be pi k. So if that would be one rotation, one positive rotation, it would be we'd have a y value of 0 at angle pi. We would have a angle of 2 pi and a y value of 0. 3 pi, a y value of 0. At negative 2 pi, we have a y value of 0. If we wanted to continue on, we could tell that at 10 pi, if I were to continue to draw my sine curve, at 10 pi, I will have a y value of 0 on my sine curve. At negative 200 pi, I will have a y value of 0. Okay, and again, I only needed one statement because my y value is repeated at regular intervals. So now, let's move on to our next one. So this is going to get a bit, I'm hoping it won't get too overcrowded. So let's look, where do we have a y value, oops, my apologies, of negative 1/2. So I've located those on my sine curve. My next question to myself is, do those y values repeat at regular intervals? And when I look at the distance between my points, I can tell that the distance between those y values are not the same. So they do not repeat at regular intervals, which means I will need to write two general statements. So I'm going to give you a moment to come up with what you think those general statements might be. Okay, so let's take a look at this one together. So I am going to look at, I know I need two statements. So I'm going to look at, I see I'm rising to a y value of -1/2. So I'm going to look at my rising statement. So I see on my diagram, I have rising to in two spots. Maybe I look back and go, okay, that's going to be a -π/6. So I have theta will be a -π/6. So that's my starting point. I could have also chosen instead that theta equals 11π/6. Totally fine. And I know in order to get to that next spot, though, of where I'm rising to a y value of -1/2, I'm going to have to add 2π. And since I want it to be general for any statement, I'm going to have 2πk. K is an element of integers. And again, I use that as my rising to. I then can look at where am I falling to a y value of -1/2. And I notice, okay, that's going to occur after a full rotation. I notice I'm 1π/6 past pi. So that tells me that I can be falling to a y value of -1/2 at 7π/6 plus 2πk, because I'm talking about a general statement. K is an element of integers. Instead, maybe I didn't want to use a 7π/6, but I used a -5π/6 plus 2πk. Also perfectly correct. So now our next one is asking, when will we be at a y value of -1? So when will we be at a y value of -1? So first, let's identify where that is. Our next question is, does that repeat at a regular interval? So do my y values repeat at a regular interval? And when I look at the distance between them, and then if I were to repeat again, I notice that they repeat at a regular interval. So what that means is I need one statement. So then that means I have to pick a starting point for that statement. So maybe you chose 3π/2. And we know it repeats every 2π. It's a full rotation later. So on our sine curve, it's going to be a full rotation. We picture that. That's going to get to our y value of -1. So it's going to be a full rotation. Maybe instead of starting with 3π/2, you started with theta equals -π/2 plus 2πk. Again, perfectly correct. So the last one that I want to go through with you is we're being asked for what values of theta do we have y values of -√3/2. So when we think about where that's located on our curve, it's -√3/2. So I'm going to just draw those on. And once I've identified where those values are, the next question I'm asking myself, do those y values repeat at regular intervals? And I'm really hoping we're noticing that no, the distance between the points is not the same, right? The distance between these 2 points is not the same as the distance it would take to get all the way back to here. So that tells us that we cannot write one general statement, because I need to be able to write statements. How do you write a general statement that talks about, well, I'm going to add this here, a smaller amount here, and then a bigger amount? So that's why we have to write these two statements, is to take into account what's happening. So again, let's think about it as rising to or falling to. And so I can identify that I am rising to a y value of negative root 3 over 2. And I follow along my sine curve and I realize I'm rising to that point an entire rotation later. And so maybe I choose theta is equal to a negative pi by 3 plus 2 pi k. Again, each grid line's pi by 6, so 2 grid lines would be pi by 3. Maybe instead of a negative 5 pi by 3, you chose positive 5 pi by 3 plus 2 pi k. Also correct. And then for my other statement, I can look at when am I falling to that y value of negative root 3 over 2. I'm falling to it. I rotate 2 pi later and I fall to that value again. So maybe I look at it and go, okay, I'm pi by 3 past pi. So pi by 3 past pi means I have an extra pi by 3. So that's going to be a 4 pi by 3 plus 2 pi k. K is an element of integers. So again, I was using my information of when is my curve rising to that y value and when is it falling to that y value to help me to identify the difference of my statements and where they would then repeat at regular intervals.